A production system goes down, the on-call engineer stares at the stack trace and freezes, not because the bug's complex, but because, for the past 8 months, an AI tool had been writing, reviewing, and explaining every piece of code he touched. His debugging muscle had quietly atrophied. This is not a hypothetical. In 2024, METR, the Model Evaluation and Threat Research Organization, published a controlled study that shook the developer community. Experienced software engineers and AI assistants actually completed their assigned tasks 50% slower than those working without it. Let that sink in. These were not junior developers. These were experienced engineers who believed they were being more productive. The AI was generating output, but the engineers had lost the ability to critically evaluate, debug, and extend that output under pressure. The tool had become a crutch, and nobody noticed until the system failed. This is the silent skill decay. It does not announce itself. It accumulates invisibly, one delegated decision at a time. By the end of this lecture, you will have a precise diagnostic framework to measure exactly how much decay has already happened in your own workflow, and a concrete system to reverse it. So what is actually happening inside the developer's mind when they rely on AI tools? There is a well-documented cognitive phenomenon called the illusion of competence. When you read an explanation, watch a solution, or accept a generated answer, your brain registers a feeling of understanding. It feels like knowing. But feeling like you know and actually being able to reconstruct knowledge under pressure are two completely different cognitive states. Psychologists call this the fluency illusion. The AI's output is fluent, coherent, and confident. Your brain borrows that fluency and mistakenly attributes it to your own internal model. Now here is where it gets dangerous. Every time you accept AI output without deeply processing it, you are practicing a form of cognitive offloading. You are not building a mental model, you are building a dependency. Automation bias, originally studied in aviation, where pilots overtrusted autopilot systems, maps almost perfectly onto this developer behavior. The pilot still feels in control. The developer still feels productive. But the underlying skill that the tool was supposed to augment is no longer being exercised, and it begins plateau, then regress. But here is the question that most discussions miss entirely. Is this decay inevitable? Or is there a specific pattern of AI usage that prevents it, and even accelerates growth? That is exactly what the cognitive science framework in the next section will reveal. Before we go deeper into the cognitive science, let me be explicit about what this lecture will actually give you. Because a lecture about learning design should itself be a model of good learning design. This is not a motivational talk about using AI responsibly. By the end of 6 chapters, you will have 3 specific, measurable capabilities. First, you will be able to diagnose your own AI usage pattern with precision, identifying whether you are in the growth zone, the plateau zone, or the dependency zone, using a concrete behavioral taxonomy drawn from cognitive load theory. Second, you will know exactly which categories of development tasks should never be fully delegated to AI, not as a vague principle, but as a structured decision framework tied to how long-term memory consolidation actually works. Third, you will have a weekly practice system, a specific schedule and exercise format that forces genuine skill formation even when you continue using AI tools heavily in your daily work. These are not soft suggestions. They are engineered interventions based on deliberate practice research. The same framework that explains why some developers with 10 years of experience are still growing exponentially, while others with the same tenure have effectively been in stagnation for the last 6. The difference is not talent, it is structure. And we are going to that structure together. Here is the full map of where we are going. Think of this lecture as a 3-layer architecture. The foundation layer, chapters 1, establishes the cognitives. Why do humans form durable skills? What does deliberate practice actually require neurologically? And how does AI tool usage interfere with or support those mechanisms? This is not background filler. Without this layer, every practical recommendation is just a tip, easy to forget and impossible to adapt. The middle layer, chapters 3 and 4, applies that science to classify real developer growth patterns. We will look at 4 distinct trajectories: the accelerator, the plateau developer, the dependency trap, and the deliberate integrator. You will recognize yourself in at least one of these patterns. The top layer, chapter 6, is pure prescription. How do you redesign your learning environment so that AI amplifies skill formation instead of replacing it? What does a Monday morning practice session actually look like? And how do you measure whether it is working? Each layer builds on the previous one. Skip the foundation and the prescription feels arbitrary. Go through all 3 and you will have a coherent, self-sustaining system. Now, to build that foundation properly, we first need to understand something that most developers have never formally studied: how human expertise is actually constructed inside the brain. That is exactly where Chapter 2 begins. In the previous chapter, we saw how skill decay happens silently. Now the question is why? Why does using AI tools cause decay at the neurological level? The answer lies in cognitive load theory, developed by John Sweller in the late 1980s. Sweller identified that human working memory is severely limited. We can hold roughly 4 chunks of information at any one time. But long-term memory, essentially unlimited. The bridge between them is called schema formation, the process of compressing complex patterns into reusable mental structures. There are 3 types of cognitive load: intrinsic load, the inherent complexity of the task itself; extraneous load, unnecessary friction from poor presentation or tool confusion; and germane load, the productive mental effort that actually builds new schemas. Here is the critical insight: your brain only grows when germane load is activated. When a task is too easy, no new schemas form. And when AI removes all the struggle from coding, is not helping your brain, it is starving it. But knowing these 3 types is just the beginning. The real danger is invisible, and it shows up the moment you open Git Copilot. Let's make this concrete with 2 developers facing the same problem: a custom binary search with edge case handling. Developer A sits with the problem. They sketch the algorithm, hit a wrong boundary condition, debug it, feel the frustration, and fix it. That frustration? That is germane load firing. Their brain is actively comparing, correcting, and encoding a new schema. Developer B opens their AI tool, pastes the problem description, and receives clean working code in 4 seconds. They read it, think looks right, and move on. Now here is what brain imaging research tells us about these 2 moments. Developer A's cortex and hippocampus are both highly active, the signature of schema encoding. Developer B's brain shows a pattern closer to passive reading, low encoding depth, minimal schema activation. The code produced may be identical. The neural outcome is completely opposite. Developer B has not learned binary search. They have learned how to ask for binary search. And those 2 things will diverge catastrophically the first time they face a problem the AI cannot pattern match. Can you predict exactly when that moment arrives? The next scene gives you the research that answers this. Now I want to introduce you to research that should permanently change how you think about feeling productive. Robert Bjork at UCLA coined the term desirable difficulties, and it is one of the most counterintuitive findings in all of learning science. His studies repeatedly showed that conditions which feel harder and slower during practice produce dramatically stronger long-term retention and transfer to novel problems. Retrieval practice, forcing yourself to recall information without looking it up, feels painful and inefficient, but it outperforms rereading by 50 to 150% in long-term retention tests. Spaced repetition feels like forgetting. But that forgetting is actually the brain strengthening the retrieval pathway when it finally succeeds. Here is the dangerous illusion. When AI gives you instant answers, the learning feels smooth and fast. You feel productive. You feel competent. That feeling of fluency is precisely the signal that no durable learning is occurring. Bjork called this the illusion of knowing. You can follow the solution, so you believe you could generate it. These are not the same cognitive operation. The developers who will dominate the next decade are not the ones who feel most productive today. They are the ones who deliberately engineer into their workflow. In the next section, we will show you exactly how that engineering works. Anders Ericsson spent 30 years studying world-class experts, chess grandmasters, concert pianists, elite surgeons, trying to identify what actually produces exceptional skill. His conclusion was precise and uncomfortable. It is not experience. It is not raw talent. It is deliberate practice, a very specific form of training with 4 non-negotiable components. You must operate just beyond your current ability level, too easy, not overwhelming. You need immediate and specific feedback on what went wrong. Third, you must mentally represent what correct performance looks and feels like. And fourth, you must repeat with full concentration, not autopilot. Now here is what developers actually do. They write code every day. They ship features. They solve tickets. They feel busy and productive. But they are executing within their existing skill envelope. No stretch target. No immediate corrective feedback. No mental model comparison. This is fluent repetition, high volume, low growth. A developer who writes 10,000 lines of code the same way they wrote their 1,000 lines has not practiced for 10,000 lines. They have repeated their current skill level 10,000 times. The question that terrifies you is, how much of your daily AI-assisted coding falls into this category? Now let's place an AI coding tool directly inside the deliberate practice loop and watch what happens. A developer encounters a problem they cannot immediately solve. This is the stretch target phase, the exact moment where skill growth begins. Their brain enters productive struggle. Hypotheses form. Dead ends are hit. The cognitive machinery schema encoding is spinning up. And then, they open Copilot. Under 5 seconds, the solution appears. The struggle phase is terminated. The developer reads the output, perhaps understands it at the surface level, and moves on. What just happened at the level of skill formation? The feedback loop was not completed, it was bypassed. The developer never generated a mental representation of the correct solution on their own. They never experienced the corrective signal that only comes from being wrong and discovering why. The schema consolidation that would have occurred never fired. Now multiply this pattern across 8 hours a day, 5 days a week for 2 years. The developer has not been practicing for 2 years. They have been using a tool for 2 years. And the critical distinction, confirmed in Erickson's research on expert development, is that tool proficiency and domain expertise develop through entire cognitive pathways. One does not automatically produce the other. This is not an argument against using AI tools. It is a precise map of which cognitive function gets disabled when you do. And in the next section, we will show you exactly where on the knowledge spectrum that damage accumulates. Cognitive scientists distinguish 3 fundamentally different levels of knowledge, and understanding where you are on this spectrum is the most important diagnostic developer can run on themselves. Level 1 is declarative knowledge, knowing facts and definitions. You can explain what a hash table is. You can describe Big O notation. This is the knowledge you demonstrate in a quiz or a blog post. Level 2 is procedural knowledge, knowing how to perform a task. You can implement a hash table. You can choose the right data structure for a given problem. This requires practice, not just reading. Level 3 is tacit expertise, knowing without thinking. The expert developer who glances a codebase and immediately senses where the performance bottleneck before running any profiler. They cannot fully articulate why they know. It is pattern recognition operating below conscious awareness, built through years of deliberate error and correction. Here is the brutal truth about AI-assisted development. It is exceptional at transferring level 1 knowledge instantly. It provides reasonable scaffolding for level 2 work. But level 3 tacit expertise, the thing that makes a developer genuinely irreplaceable, cannot be absorbed from an AI output. It can only be grown through the cycle of failure, diagnosis, and correction performed by your own cognitive system. Most developers using AI tools today are building an impressive level 1 library on top of an increasingly fragile level 2 foundation. And their level 3 is not developing at all. This brings us to one of the most dangerous phenomena in modern software development, what I call tool-dependent knowledge. This is knowledge that appears to exist when the tool is present, but collapses the moment the tool is removed. You have seen this in technical interviews. A candidate who has shipped production code for 3 years freezes when asked to implement something they have only ever done with AI assistance. They are not faking their experience. They genuinely built those features. But the knowledge was encoded in the interaction with the tool, not in their own cognitive schema. This is context collapse. The knowledge cannot travel outside the environment where it was formed. The consequences are not limited to interviews. Consider a production incident at 2 a.m. with no internet access. Consider onboarding to a legacy codebase with no AI context window large enough to hold it. Consider the moment when an AI tool hallucinates a solution to a novel architecture problem you have never seen before, and you have no independent judgment to detect the error. Tool-dependent knowledge is not partial knowledge. In high-stakes moments, it functions as zero knowledge. The developers who understand this distinction and deliberately design their learning to build portable, internalized expertise are the ones building something that compounds. Everyone else is building a dependency. And in the next chapter, we will show you exactly which trajectory you are currently on and how to switch tracks before it is too late. Not all AI usage is created equal, and this is the insight most developers miss entirely. We can classify every developer's relationship with AI coding tools across 2 critical axes: cognitive engagement level, meaning how much mental effort you are actively investing, and task ownership, meaning who is ultimately responsible for understanding the solution. When you plot these 2 dimensions against each other, 4 distinct patterns emerge. The scaffolded learner uses AI with high engagement and full ownership. AI is a thinking partner, not an answer machine. The accelerated expert delegates routine tasks to AI while maintaining deep ownership of the architecture. These 2 patterns compound skill over time. But the passive consumer copies AI output without interrogating it, and the dependent operator cannot function without AI prompts for even basic decisions. These 2 patterns look productive on Monday and hollow by month 6. The taxonomy you are about to see is not a judgment, it is a diagnostic tool. And most developers, if they are honest, will recognize themselves in at least one stagnation pattern right now. Let us zoom into the 2 patterns where real growth happens, because the behavioral difference between a scaffolded learner and an accelerated is subtle but consequent. The scaffolded learner treats every AI-generated code block as hypothesis, not an answer. They read it, predict what it should do, run it mentally, and test it. When the AI gives them a sorting algorithm, they ask, why this algorithm? What is its time complexity? Could I have written this without the AI? This is deliberate practice embedded inside AI-assisted work. The accelerated expert operates differently. They already have the mental model. They use AI to eliminate boilerplate, the code they could write themselves but would rather not. When they review AI output, they are not learning from it. They are auditing it against a schema they already own. Here is the critical distinction. Both patterns maintain cognitive ownership. The scaffolded learner builds the schema through the AI interaction. The accelerated expert verifies against a schema already built. Both grow. But if you cannot tell which one you are, that is a warning sign. Ask yourself, when AI gives you code, can you predict what it will do before you run it? If the answer is no, you are not in either of these two patterns. Now the uncomfortable half. The passive consumer and the dependent operator share one defining trait. They mistake output speed for skill growth. The passive consumer has not made a conscious choice to depend on AI. It happened gradually. They started copy-pasting AI solutions because it was faster. Then they stopped reading the full output because it usually worked. Then they stopped attempting problems before querying AI because why waste time? Each step felt rational. Each step eroded one layer of the schema-building process that cognitive science tells us is irreplaceable. The early warning signs are specific. You cannot explain your own code in a technical interview. You feel lost when AI gives you two contradictory solutions, and you have no basis to choose, and your debugging instinct, the ability to form a hypothesis about where the fault has become dull. The dependent operator is further along the same path. They experience what researchers call skill atrophy, not forgetting facts, but losing the procedural fluency that only comes from repeated effortful practice. Here is the most dangerous part. Both patterns feel fine from the inside. Productivity dashboards look green. PRs are emerging. The atrophy is invisible until a high-stakes moment. A system design interview, a production incident, promotion decision, makes it suddenly, painfully visible. And that moment, as you will see in the next section, tends to arrive at a very specific point in the 12-month curve. The divergence between growth positive and stagnation patterns is not theoretical. It follows a measurable curve with a predictable shape. METR's 2024 research on AI-assisted developer task performance gives us a concrete anchor. Developers using high delegation AI workflows showed a 55% reduction in task completion time in the first 90 days. This number gets cited everywhere as proof that AI accelerates developers. What gets cited far less is what happened to the same cohort's performance on novel tasks. Problems the AI had not seen patterned before. By month 6, the velocity gains flatlined. Worse, performance on complex debugging and architecture tasks showed regression compared to a control group that used AI more conservatively. Meanwhile, developers in structured AI usage patterns, those who maintain deliberate practice habits alongside AI tooling, showed a compounding curve. Slower velocity gains early, but skill growth that accelerated after month 3, because their schemas were getting richer, not poorer. This is the insight from Anders Ericsson's deliberate practice research applied to AI tools that eliminate struggle, eliminate the very mechanism that produces durable expertise. The short-term productivity graph and the long-term skill graph are not the same graph. Most developers are only looking at one of them. The curve is abstract until you hit one of 3 specific inflection points. Moments where the knowledge debt you have been accumulating suddenly becomes a hard, visible liability. The first inflection point is the technical interview. Most mid-level technical interviews require you to produce working logic from a blank slate, explain your reasoning aloud, and adapt under pressure. These are precisely the skills that high delegation AI usage atrophies. Developers who have been shipping AI-assisted code for 6 to 12 months without deliberate practice report a jarring disconnect. They know what good code looks like when the AI produces it, but they cannot produce it themselves under observation. The second inflection point is the senior promotion review. Senior engineering requires you to defend architectural decisions, not just implement them. When a staff engineer asks you why you chose this data structure, or what the failure modes of this design are, AI cannot answer for you in real time. The third and most consequential inflection point is architecture ownership transition, the moment you are asked to design a system from scratch and own the trade-offs. This requires a density of internalized patterns that cannot be borrowed from an AI prompt. Each of these inflection points arrives on a predictable timeline. The question is not whether you will encounter them. The question is whether your learning habits over the past 12 months have prepared you to pass through them, or whether they have quietly set you up to fail. In the next section, we will see that this risk is not distributed equally across experience levels. Here is a finding that surprises most team leads. Junior developers and senior developers are both at risk from AI overdelegation, but for completely different reasons, with completely different failure modes. Let us start with junior developers. The foundational risk for a junior is what cognitive scientists call schema poverty, a state where you do not yet have enough internalized patterns to evaluate the quality of information you receive. This creates a particularly dangerous feedback loop with AI. When a junior developer queries an AI for a solution and receives code that runs without errors, they have no reliable mechanism to determine whether that solution is idiomatic, whether it handles edge cases, whether it will scale, or whether it has introduced a subtle security vulnerability. The code works, so the junior accepts it, and more dangerously, they internalize it as a correct pattern. They are not learning from the AI. They are being misinformed by it at scale faster than any previous generation of developers. Traditional learning environments corrected this through code review, pair programming, and the slow accumulation of mentor feedback. AI assist flows can bypass all of these correction mechanisms entirely, especially in teams where senior capacity for review is already stretched. The junior developer, who relies heavily on AI before building foundational schemas, is not accelerating their growth. They are building a tower on sand, and the tower will look fine until the first real load test. So what does the right intervention look like for a junior? That is exactly what the next section will show you. But first, let us see why seniors are not safe either. Senior developers face a risk that is almost the mirror image, and it is more insidious precisely because it is invisible for so longer. Seniors have rich schemas. They built them over years of effortful, often painful practice. This means they can evaluate AI output correctly. They are not in the schema poverty trap. But here is the paradox. Because they can evaluate AI out correctly, they feel competent while outsourcing the cognitive work of producing that output themselves. And competence is a feeling, not just a capability. Tacit expertise, the kind that lives in procedural memory, the kind that lets a senior developer at a system diagram and immediately feel where the bottleneck is maintained only through regular exercise. It is the same principle that applies to any expert skill domain. A surgeon who stops operating does not stay surgical. The skills that are not actively exercised undergo what researchers call use it or lose it degradation. For senior developers, this degradation is particularly dangerous because the subjective feeling of competence persists long after the underlying procedural fluency has weakened. A senior developer who has been using AI for deep implementation work for 12 months may still sharp until they sit in a system design whiteboard session without an AI assist and realize their pattern retrieval speed has slowed, their edge case instinct has dulled, and their ability to hold multiple architectural constraints in working memory simultaneously has degraded. This is the hidden cost of high delegation AI usage at the senior level. And it is a cost that does not appear on any sprint dashboard. The question that follows naturally from everything we have covered in this chapter is, what does learning system that's both of these failure modes actually look like? That is exactly where we are headed in Chapter 4. And the answer involves a design principle that most developers have never explicitly applied to their own growth. In the previous chapter, we saw two diverging trajectories, developers who grew stronger alongside AI, and those who quietly atrophied. The question now, what structural difference separated them? The answer is not willpower or talent. It is architecture, specifically, how they architected the boundary between human cognition and machine delegation. Today, I am introducing the three-zone model, a cognitive load-aware framework for deciding exactly where AI should enter your workflow, where it should assist, and where it must never touch. Zone 1 is the no-delegation zone, the territory where your schemas are still forming and where delegation destroys the very learning signal you need. Zone 2 is the augmentation zone, where AI acts as a second opinion, accelerating iteration without replacing judgment. Zone 3 is the automation zone, low cognitive growth tasks, where full delegation is not only safe but strategically necessary to reclaim bandwidth for Zone 1. This single framework, applied consistently, is what separates developers who compound versus developers who coast. But here is the uncomfortable truth. Most developers have the zones exactly backwards, and we will prove that in the next scene. Let us be precise about what belongs in Zone 1, the no delegation zone, because vagueness here is fatal. Cognitive science, specifically the work of Anders Ericsson on deliberate practice and John Sweller on cognitive load theory, gives us a clear criterion. A task belongs in Zone 1 if and only if the productive struggle during that task is the mechanism by which your long-term memory schema is encoded. First draft algorithm design. When you ask AI to generate your initial approach to a problem, you bypass the constraint satisfaction process that builds algorithmic intuition. You must form your hypothesis before consulting any external source. Second, root cause debugging. Tracing a bug through system layers, forming and falsifying hypotheses. This is precisely the activity that builds your mental model of how systems fail. AI-assisted debugging short-circuits this entirely. Third, system decomposition and architecture decisions. How you break a problem into components is a direct readout of your conceptual model. Delegating this means your model never gets tested, never gets corrected, never matures. Fourth, writing code explanations in your own words, not paraphrasing AI output, but generating explanation from your own retrieval. Each of these is non-negotiable. The moment you delegate them, you are not saving time. You are spending your future skill as currency. But what about everything else? That is where the automation zone becomes your secret weapon. And that is exactly what we examine next. Now here is the strategic flip side, and this is where most developers leave enormous valuable. The automation zone is not a compromise, it is a force multiplier. Every hour you spend manually writing boilerplate, generating routine test scaffolding, or formatting documentation is an hour stolen from Zone 1 deliberate practice. The cognitive science is unambiguous. Working memory capacity is finite. Miller's law gives us 7 plus or minus 2 chunks. And any attention consumed by low-growth mechanical tasks directly reduces the depth available for schema-building work. So let us be explicit. Boilerplate code generation. Fully delegate. Standard SURAD scaffolding, repetitive configuration files, language idiomatic patterns you already understand, hand these to AI completely. Test case generation for known logic. Delegate. Once you understand what a function does, generating the test matrix is mechanical. Documentation drafts for understood code. Delegate. You review and correct, but you do not generate from scratch. Commit message formatting, changelog structuring, code formatting and linting passes, all Zone 3. The reclaimed hours are not cache time, they are reinvested directly into Zone 1. This is the compounding engine. Developers who master this reallocation are not working harder, they are structurally guaranteed to grow faster. And now that we have the zone boundaries clear, the next section answers the hardest question. How do you actually schedule this in a real work week? Knowing the zone model is necessary but not sufficient. Without a concrete weekly schedule, the no delegation zone collapses under deadline pressure within 2 weeks. Every experienced team lead has watched this happen. So we are going to prescribe a specific weekly structure grounded in 2 bodies of learning science. Erickson's deliberate practice framework, which requires that growth activities be scheduled as protected time, not leftover time, and the spacing of research from Ebbinghaus through modern cognitive psychology, which tells us that retrieval practice distributed across days produces 4 times long-term retention than equivalent mass practice. Here is the structure. Monday and Thursday, AI-free coding sessions, 90 minutes each, calendar blocked, no AI tools open. This is your Zone 1 protected time. Tuesday and Friday, spaced retrieval review. 30 minutes reviewing concepts encountered earlier in the week. Write explanations from memory before checking any source. Wednesday and Saturday, AI-augmented build sessions. Use AI freely for Zone 3 tasks, but enforce the augmentation zone rules for any design or architectural decision. Sunday, weekly error analysis review. We will cover this in detail shortly. This is not a productivity schedule. This is a neurological growth schedule. The spacing between AI-free sessions is not inefficiency. It is the consolidation window that your hippocampus requires for long-term potentiation. Skip it, and you are farming without letting the soil recover. But the schedule alone is still not enough. You need daily micro-practices that reinforce the boundary even inside your regular work hours. Those 3 practices are coming next. The weekly schedule sets the macro structure. But your real growth happens at the micro level, in the small decisions you make dozens of times per day, every time you reach for AI assistance. Here are 3 daily micro-practices that act as cognitive immune system responses against passive consumption. Practice 1. Predict then check. Before submitting any query to an AI tool, write or mentally articulate your own answer first. Even a rough, incomplete answer. Research on the generation effect, Slimeca and Graf, 1978, replicated extensively, shows that attempting to produce an answer before receiving it dramatically increases subsequent retention of the correct answer, even if your initial attempt was wrong. The attempt itself is the learning mechanism. Practice 2. Explain before accept. When AI returns a code suggestion, before you accept it, you must articulate, out loud or in writing, why this solution works, not summarize what AI said. Explain from your own understanding. If you cannot do this, you have found a Zone 1 learning gap that requires deliberate practice, not delegation. Practice 3. AI Cold Daily Problem. Solve one problem, code K, a design question, a debugging scenario, with AI tools completely closed, not minimized, closed. The presence of a safety net changes how your brain allocates effort. Psychologists, the desirable difficulty principle. These three practices require less than 30 additional minutes per day total, yet they are the difference between using AI as a telescope, extending your vision, versus using it as a wheelchair, replacing your legs. The next scene addresses what happens when you do a mistake in this system, and how to turn it into compound interest. There is a silent feature of the pre-AI development environment that almost nobody talks about, yet cognitive scientists would immediately identify it as a primary growth driver: the feedback loop. When you wrote code without AI assistance, and it failed, the failure was yours, the error message was specific, the debugging trace was traceable, and the lesson was encoded directly into your schema through the emotional and cognitive weight of the struggle. AI assistance has severed this loop. When AI writes code and it fails, the failure signal is diffuse. You do not know if you would have made the same mistake. You cannot easily distinguish your knowledge gaps from AI's generation artifacts. And the emotional weight, which is actually a neurological encoding amplifier, is minimal. The error analysis journal is how you restore this loop intentionally. The protocol is simple but non-negotiable. Every time an AI suggestion contains an error that you catch, or miss and discover later, you record three things: the category of error, what conceptual model failure it reveals, and the Zone 1 practice task that would close that gap. Over weeks, this journal becomes a personalized curriculum, a map of exactly where your schema has holes that AI has been papering over. This is precisely the methodology used in expert skill development across domains, from chess grandmaster training cataloged by de Groot to circle skill development protocols in medical education. Your mistake catalog is your most valuable learning asset. And with that system now in place, the final question of this chapter becomes: what if you could make AI itself into your most effective teacher? That is exactly what Section 3 will show you. Everything we have discussed so far assumes that when you do use AI, you use it in a way that builds your cognition rather than replacing it. And this is where the single most high-leverage behavioral change in this entire lecture lies. It is not about time allocation or scheduling, it is about posture. Specifically, the posture with which you formulate your AI queries. Most developers approach AI with an answer-seeking posture. The implicit question is, give me the solution. The AI obliges. The developer accepts. Cognitive engagement, near zero. Schema update. This is the pattern that produces what we called the plateau developer in the previous chapter. The Socratic posture is structurally different. The implicit question is, help me understand. And the specific prompt structures that instantiate this are concrete and learnable. Compare these two prompts directly. Answer seeking. Write a function that debounces API calls in React. Socratic. I want to understand the closure behavior that makes debounce work. What question should I be asking myself to design this, and what would the answer reveal about JavaScript event loop timing? Do you feel the difference? The second prompt forces the AI into a teaching role, but more importantly, it forces you into an active reasoning role before the response even arrives. This is elaborative interrogation, a retrieval-enhancing technique documented extensively in cognitive psychology since the 1980s. The prompt itself is a Zone 1 activity. But there is an even more powerful technique that goes one step further, and it uses AI in a way almost no developer has considered. It is coming in the final scene. Final technique in this chapter is the most counterintuitive and the most powerful. It is called the teaching back technique, and it inverts the entire human-AI interaction model you have been trained to assume. Instead of querying AI for answers, you speak to AI as your audience while you explain your own understanding. The cognitive science foundation is the generation effect combined with the protégé effect. Research by Nestojko and colleagues at Washington University showed that students who expected to teach material to others encoded it more deeply, organized it more coherently, and retained it longer than students who studied for their own test. Here, the protocol. After completing any learning session, reading documentation, watching a tutorial, finishing a Zone 1 practice task, you open your AI tool and you say, I am going to explain what I just learned about X. Please listen, and then ask me the hardest question that reveals whether I truly understand it versus merely recognize the pattern. Then you explain, aloud or typed, your own words. No notes. The AI's follow-up question then functions as a Socratic probe, revealing where your explanation was shallow, where you substituted fluency for understanding, where your mental model has load-bearing assumptions you never examined. This technique transforms AI from an answer machine into a Socratic partner. And notice, in this mode, the AI is not doing your cognitive work. It is providing the social pressure and the probing question that forces your own cognitive work to go deeper. Developers who build this habit report that within 8 weeks, their ability to explain and reason about complex systems. Exactly the skill that distinguishes senior developers in technical interviews and architecture reviews, improves measurably. In the next chapter, we move from individual practice to team dynamics. How do team leads scale this framework, and what does the enterprise reality of AI adoption actually look like on the ground? Here is what the best engineering organizations have already figured out, and what most teams are getting dangerously wrong. Top-tier companies like Stripe, Shopify, and Netflix are not giving developers a blanket use AI however you want policy. They are implementing tiered AI governance frameworks. The logic is surgical. AI assistance permitted at the production code layer for boilerplate, test generation, and documentation. But in designated learning sprints and architectural decision sessions, AI access is deliberately restricted. Why? Because they have read the same cognitive science you learned in Chapter 4, that retrieval practice and productive struggle, the mechanisms of internalization. If you bypass those mechanisms at every touchpoint, you are not building a high-velocity team. You are building a team with a hidden skill debt that will surface at exactly the worst moment, during an incident or a system design review. The governance structure is not about distrust. It is about protecting the conditions under which real expertise forms. But here is the uncomfortable question this raises for team leads, and we will see the full answer in the next scene. So how does a team lead actually operationalize this? The answer is not a single policy memo. It is a systematic change to the rituals that shape developer growth. Code review, pair programming, and mentorship check-ins. In the pre-AI era, code review was implicitly a knowledge transfer mechanism. A senior engineer would flag an inefficient pattern, and the junior would internalize the principle. In an AI default environment, the junior submits AI-generated code that is syntactically clean, and the reviewer has no visible signal of whether the developer understood anything at all. This is the stealth failure mode. The playbook fix is to shift code review auditing to understanding auditing. Concretely, reviewers ask walk me through why you structured this transaction boundary here rather than just approving clean diffs. Pair programming sessions are restructured, so the junior drives while the AI suggestion is visible, but not immediately accepted. The junior must verbalize acceptance or rejection reasoning. And in one-on-ones, team leads run a 60-second AI probe. Explain this function you shipped without looking at the code. If the developer cannot, the learning did not happen, only the output did. The gap between output quality and developer capability is the single most dangerous metric blind spot in engineering management today. There is a ceiling in software engineering where AI assistance quietly stops working. And most developers do not discover it until they are already standing underneath it with no way to climb further. That ceiling is architectural reasoning, not system design templates. Those AI can reproduce fluently. The actual ceiling is the class of decisions that require contextual judgment layered on organizational history, internalized failure pattern, and domain-specific constraint reasoning. Consider a concrete example. You are deciding whether to decompose a monolith into microservices for a financial platform. An AI model will give you a coherent answer based on the general surface area of that question. But the correct answer for your organization depends on your team's actual operational maturity, your deployment pipeline reliability, your regulatory audit trail requirements, and the 2 previous outages that taught you where your data consistency assumptions were wrong. None of that context exists in a prompt, and the ability to weight those factors correctly. That is not pattern retrieval. That is internalized tacit knowledge accumulated through systems that failed under you and through architectural decisions that forced you to live with their consequences for years. This is precisely what ISO team quality models call architectural fitness for context. And it is the domain where senior engineers and staff engineers earn their differential. The gap is visible on a day-to-day productivity dashboard, but it surfaces dramatically and suddenly. And the next scene will show you exactly when. The moment the ceiling becomes visible is always the same. It is the senior IC promotion panel, the staff engineer system design interview, or the first time a developer is handed ownership of a critical architectural decision without a safety net. And in the post-AI era, this moment is arriving faster and hitting harder. Here is what engineering managers at companies like Airbnb and LinkedIn are reporting privately. A cohort of developers who were highly productive individually, strong velocity metrics, clean PRs, fast feature delivery, completely stalled at the senior promotion threshold. Not because they lacked effort, because they had systematically outsourced the thinking that builds architectural, and they had traded deliberate struggle for consistent output and the knowledge debt had been silently compounding since their first year. The career consequence is not gradual, it is a cliff. Developers who built internalized depth show exponential leverage at the senior to staff transition. Developers who optimized for AI-mediated output that no amount of additional prompting can overcome. The question is not whether you will reach this ceiling. This is whether you will have built the foundation to break through it, or whether you will have spent your growth years renting answers instead of building understanding. And in the next section, we give you the diagnostic tools to find out exactly you stand right now. Everything we have discussed in this lecture converges on a single practical question. How do you actually know if you are growing? Because in the AI era, the most dangerous state is high output with declining capability. And your standard productivity dashboard will not tell you which one you are in. Here is a quarterly self-assessment protocol built on the same transfer testing principles used in cognitive load research and professional certification frameworks, including the methodology behind information management and technical certification exams. First, the AI off benchmark. Once per quarter, take a class of problems you normally solve with AI assistance and solve them in a timed, AI-free environment. Not prove you can, to measure delta. If your AI off performance on problem categories you have worked on for 6 months is not improving, your learning is not happening, your output is. Second, the novel domain transfer test. Pick a domain adjacent to your daily work that you have never touched with AI. Attempt to architect a solution. The quality of your reasoning in a domain where AI cannot compensate reveals the actual portability of your understanding. Third, the explanation clarity audit. Take the 3 most complex things you ship this quarter and explain them to a non-expert without referencing code or documentation. If you cannot, you did not learn it. These 3 tests are not about ego. They are early warning signals, and catching them quarterly is infinitely cheaper than discovering the truth at your promotion panel. Now here is the subtlety that trips up even experienced engineers and their managers. Leading indicators and lagging indicators of developer growth are completely different metrics, and they are almost never displayed on the same dashboard. Lagging indicators are what most teams measure: pull request throughput, feature velocity, ticket closure rate, lines of code shipped. These are output metrics. They are real. They matter for delivery, but they are trailing measurements of productivity. And in an AI-assisted environment, they can increase while actual developer capability simultaneously decreases. Leading indicators are what predict future capability. The rate of improvement on AI off benchmarks, the breadth of problem domains where the developer can reason without scaffolding, the quality of their written technical rationale in design documents, and the accuracy of their effort estimates on genuinely novel problems. A developer with declining leading indicators but strong lagging indicators is a system with growing technical debt, and the debt will be called in. The management implication is direct. Engineering organizations that optimize only for lagging indicators are unknowingly selecting for AI dependency over expertise. The developers who will be most valuable in 5 years are those whose leading indicators are climbing now, even if their lagging indicators look identical to their AI-dependent peers today. That distinction is the entire thesis of this lecture. In our final chapter, we will show you exactly what the developer who wins the next decade looks like in practice. Let's pull everything together. Over the past 5 chapters, we've built a complete cognitive science framework for AI-era development. The center sits one irreducible truth. Your brain's pathways only strengthen through effortful retrieval, not through observation of AI output. Cognitive load theory tells us that germane load, the load that builds schema, only activates when you are the one doing the thinking. The 4 usage patterns we mapped, passive consumer, prompt engineer, strategic delegator, and cognitive architect, form a spectrum. Most developers reading anxiety-inducing LinkedIn posts are stuck at pattern 1 or 2, believing tool fluency equals skill growth. The 3-zone model corrects this. Your no delegation zone is sacred ground where schema formation happens. Your supervised delegation zone is where you verify and interrogate AI output, keeping your critical faculties sharp. And your full delegation handles only the genuinely mechanical tasks that consume time without building expertise. Finally, the weekly protocol binds it all together. Deliberate AI off sessions on Mondays, structured interrogation practice midweek, and Friday reflection that makes your learning visible. This isn't a productivity system, it's a cognitive preservation system. The question is no longer whether to use AI. The question is whether your usage pattern is compounding your expertise or quietly eroding it. And that distinction right there is what separates the developers who will lead the next decade from those who will be led by it. Now, knowledge without commitment is just entertainment. So before you close this video, I want you to make 3 concrete decisions. Not someday, not next sprint, but this week. First, identify your dominant AI usage pattern right now. Be brutally honest. Are you a passive consumer who accepts AI output without interrogation? Write it down. Naming the pattern is the first act of metacognitive control. Second, define your personal no delegation zone. What is the one class of problem in your domain? Whether it's distributed systems design, database query optimization, or security threat modeling, where you will commit to zero AI generation. This boundary is not a limitation. It is the plot of land where your expertise compounds. Third, open your calendar right now and block 90 minutes this week. Label AI off practice and treat it with the same non-negotiable weight as a production incident. Research on deliberate practice, from Ericsson's original studies to subsequent replications in software engineering contexts, consistently shows that the practitioners who schedule and protect their deliberate practice time outperform those who practice only when convenient by a factor that widens every single year. The developers who act on these three decisions today will look back in 5 years and recognize this moment as an inflection point. Those who don't will wonder why the gap kept growing. The choice is structural, and it starts right now. Charlie Munger famously said, "The first rule of compounding is never interrupt it unnecessarily." He was talking about capital. But the most powerful compounding engine available to developer is not money. It is deeply internalized knowledge. Here is the uncomfortable arithmetic of the AI era. A developer who surrenders deliberate practice for AI convenience accrue apparent productivity gains in the short term, perhaps 30 to 50% faster feature delivery in year one, but their underlying schema density flatlines. Meanwhile, a developer who preserves cognitive load, who deliberately struggles, who interrogates rather than accepts, their schema network grows denser, more interconnected, more capable of analogical transfer across domains. By year 3, the compounding gap is visible. By year 5, it is irreversible in practical terms. By year 10, one developer is debugging systems they barely understand, and the other is architecting systems no one else in the room can fully hold in their head. This is not a pessimistic view of AI. This is precisely the opposite. AI is the most powerful leverage multiplier in the history of software development. But leverage amplifies what already exists. A weak foundation leveraged becomes fragile at scale. A strong, compounded foundation leveraged becomes something entirely new. A developer who can conceive, reason about, and validate solutions at a depth and speed that was simply not possible before AI existed. That is the developer who wins the next decade. Not the one who uses AI most, but the one who has built enough depth that AI becomes a genuine force multiplier rather than a cognitive prosthetic they can no longer function without. This lecture was a single entry point into a much larger map of learning science, the cognitive science of developer growth, to 3 adjacent domains you should explore next. First, spaced repetition systems. The Ebbinghaus forgetting curve is not a metaphor. It is a precise quantitative model of memory decay. Applying spaced repetition to technical concepts, not just vocabulary, is one of the highest leverage investments a developer can make. Tools like Anki can be adapted for system design patterns, algorithm intuitions, and architectural trade-offs. Second, metacognitive monitoring. The single strongest predictor of expert performance across domains is not raw engines. It is the practitioner's ability to accurately assess their own knowledge gaps in real time. Calibrating your metacognitive accuracy, knowing what you know and knowing what you don't know, is a trainable skill that is compounding dividends. Third, knowledge graph construction. Isolated facts decay. Interconnected concepts forgetting and enable transfer. Building explicit knowledge graphs, whether in tools like Obsidian or simply on paper, externalizes the neural schema formation process and makes gaps visible before they become dangerous blind spots. Each of these topics will be covered in depth in the next lectures in this series. The learning design curriculum you've just entered is not about studying harder. It is about understanding the machinery of your own mind well enough to engineer your growth with the same rigor you bring to your systems. Thank you for staying until the end. The developers who watch this far are exactly the ones who will compound.